SwayamPrabha. Digital India. Educated India.
So, the next experiment that we are going to work on is a fitness machine. So, this is a fitness machine typically available in market for relaxing the muscles of the human body. So, what happens here is that you have a platform and on which if you stand, the platform vibrates and then excites the whole body in vibration, and then that to an extent can relax the muscles, and in different orientation you can stand on top of it, but basically it's nothing but a vibratory system in action. So, I will just start this the machine to let you understand and see how the vibrations are set up in on the platform. Yeah. So, you can see that this platform is set in vibration, and usually what happens is that you stand on top of it, and from your sole you are set in vibration. You can stand in different orientations. It's a vibratory system actually. Now, what we are supposed to do is look at the details of this platform as to how this is set in vibration and model this as a vibratory system. We will open this, disassemble the top platform and see what is there inside and what is exciting this platform, and with the parameters which we will identify, for example, what is the mass which is vibrating, what is the support mounts, the stiffness and damping associated with it, and try to estimate the vibratory response of this platform. In addition, we are going to verify that by actual measurement of the vibration of the platform. So, we have the sensors available, so we can put the sensor on top of the platform, and we are going to record what is the the vibratory displacement. So, Anuj, can you help us? So, this is an piezoelectric accelerometer which we are going to put on top of the platform. We have a arrangement for pasting, for attaching the accelerometer on the platform, and the output from the sensor is fed to a data acquisition system. So, the sensor output is fed to this data acquisition card, and the output from the data acquisition card goes to the laptop where a software acquires and stores the data. That data we are going to share with you so that you know how much is the amplitude being recorded, and by making a vibratory model, a simplified vibratory model of this physical system, we are going to analyze the vibratory response, find out what is the value of it, and we will try to compare it with what we get experimentally. That is the task in this experiment. So, I am going to again restart this. Now, when you run this type of a setup, you can imagine that there is going to be a force which is going on the ground, and so if this fitness machine is a part of a gym which is maybe in the second floor or fourth floor of a typical building, and then if the habitants on the ground floor, on the first floor, if they get irritated because of the vibrations being transmitted, you need to design the isolator of this the fitness machine in a way that the force which is transmitted, the dynamic force which is getting into the floor or the ground is minimized. So, you can design the isolators with a low transmissibility by properly designing the isolator stiffness based on the frequency of excitation and the other parameters of the system. So this is another way of looking at the practical application of the transmissibility for a vibratory system in practice. But in this case we are going to restrict ourselves to the measured data from the platform, and then we will now disassemble the platform and will show you how the whole mechanism of exciting the platform is designed. Okay. So this is how we are recording it. The accelerometer data is fed, and in the front screen you can see that the signal, of course it's not pure harmonic signal, but still the frequency spectrum shows dominating 34 hertz frequency here. So there are some high frequencies and some noise appearing, but broadly it is a sinusoidal signal that you can observe. The frequency here is the major frequency, the main frequency is 34, that's the speed or the frequency that you notice. I can check whether there are any other frequencies. So you can see that the noise would have some high frequencies there, but the major dominating frequency is the 34 hertz. So you can see that there are some high frequency components here, but broadly the dominating frequency is your rotational frequency, is the dominating one is the lower frequency of 34 hertz here. Okay, so this is that platform you are seeing upside down, and on the underside of this platform the source of excitation can now be seen. So what we have here are two electric motors which are bolted on the underside of this platform, and these motors have unbalanced masses at both ends, and so as the motor shaft spins, the unbalance mounted on the shafts they provide the excitation force to the platform, and they rotate in counterclockwise in contra rotating fashion, so that the excitation force is always vertically up and the horizontal component of it they get cancelled. So these two motors together they work in generating a vertical excitation force to the platform. In addition, what you are observing here are the isolators placed on the frame at these four corners, and so these are all called as the diamond mounts, and you can see that these mounts are flexible and they made of polymeric material, and so this acts like a stiffness element in the vibratory system. The platform along with these motor mass, that is your mass which is vibrating, and the stiffness is provided by these four mounts. Because these are of polymeric material, as the platform vibrates there is a dissipation of energy in these mounts. So the mounts are basically the spring and dashpot in one. Okay. So these four at the four corners act like a mount or an isolator, and together all four of them provides the stiffness and damping required for a simple vibratory system to function. The motors, again let me repeat that these two motors have contra rotating unbalanced masses which rotate in opposite direction, cancelling the horizontal component and only generating a net vertical excitation force to the platform. Now you will have to basically model this platform and the mount as a simple vibratory system. We can find out the stiffness of these mounts by either the static load deflection test, or you can place a mass on top of this mount and excite it vertically and record the vibration response. Now if you get a free vibration response, a decay plot, you can find out not only the stiffness of this based on the mass which is put on top of this mount. If you know the mass which is put on top of it and the stiffness is unknown, so based on the time vibration time history, you can find out the time period of oscillation, and from the time period of oscillation you can find out the stiffness, because this can be treated as a simple single degree of freedom system by hitting it vertically and recording the vibration response using an accelerometer. You can find out what is the period of oscillation. From that, because the mass is known which we put on top of this isolator, you can find out what is the stiffness of this isolator, and from that vibration time history, from the logarithmic decrement, we can find out the damping factor, the equivalent viscous damping factor for this mount. You can imagine that all these 4 mounts are identical, and therefore, the stiffness and damping can be treated identical at the 4 supports, and then your model will be complete, because you will be knowing the mass, the stiffness and the damping, and based on that, the your numerical model, once it is final, you can find out what is the vibration response. Of course, for that you will need how much is the excitation force generated in the motors. Now, by opening these motors, I can find out the unbalanced mass which is placed here and the speed of the operation of the motor. Now, from the measured data, it is quite clear that the rotational speed was 34 hertz, and if you know the unbalanced mass in the motor shaft, you can find out what is the force which is acting on this platform. Now, using that, you can find out what is the steady state unbalanced vibration response of the platform, and you can compare it with the measured data that we have. So, all these data will be provided to you as a separate input file, and you will have to work out your model from this data and then compare it with the recorded vibration data. So, that is the task in this particular experiment.